Welcome to solverfy.
All right, so we've been shown the following relative energy diagram. With points A and C, which are equivalent, E, which is slightly higher, B, which is slightly lower than D, and F. Okay. So maybe I'll color code this. D and F are the exact same energy, and A and C are the exact same energy. And then we're told that this is a diagram for 1-chloro-2-methyl-propane. And that we're supposed to imagine looking at this 1-chloro-2-methyl-propane down this particular axis right here. Okay, so remembering what we know about Newman projections and their relative energies, remember that the two possible classifications for the conformers that it can adopt would be staggered and eclipsed. Right? Staggered is when the bonds are, if we draw a Newman projection, staggered like so, right? Like they're not overlapping. And then eclipsed is when the bonds in the back overlap the bonds in the front. Okay, and staggered is always lower energy, and eclipsed is always higher energy. Okay, and so if we've been asked to identify the rotation and conformer corresponding to C, right? Then that means it has to be a staggered conformation, because the eclipsed conformation, right, is going to be B, D, and F, the higher energy ones. So it's one of the possible staggered conformations, right? Okay. And so now our other piece of information is that in the particular conformation that is represented by C, if we move the bonds, if we rotate the bonds, right, 60 degrees, we go from C to D, which is one of the eclipsed conformations, right? And if we move from to the left 30 degrees, then we move from C to B, one of the other eclipsed conformations. But importantly, one of the eclipsed conformations that we can move into, D, is higher in energy than the other one, B. Okay, so let's talk about what those eclipsed conformations are that correspond to B, D, and F, and then we'll know that we're in between two of those. Okay, so let's recall here that in order to draw this properly, right, this is just a bond line drawing that shows no wedge dash. I'm going to replace this simple bond line methyl with a wedge, and I'm going to put a hash to a hydrogen in the back. Then I'm going to put this hydrogen on a wedge and add my hydrogen in the back. Okay, so I've got my hydrogen closest to me on the right. I've got my methyl far away on the right. I've got a hydrogen on the left in the back. I've got a hydrogen on the left in the front. And then my chlorine is straight up, and this methyl is straight up. So when I draw my Newman projection for this particular image, it's going to look like the following. It's going to be eclipsed, right? Because the chlorine and this methyl are both pointing straight up. Chlorine and the methyl in the back pointing straight up. I said on the right, in the front, I've got my hydrogen, and in the back, I've got another methyl. And on the left, in the front, I've got a hydrogen. In the back, I have a hydrogen. Okay, so that's one possible eclipse conformation. Okay, is this going to be D or F or B. This could be D or F because we have a chlorine overlapping with a methyl, right? The other option, chlorine, if it's eclipsed, has to either overlap methyl, this methyl, or this methyl, or hydrogen, right? And hydrogen's not going to be nearly as bad as the methyl group, right? So B is going to correspond to chlorine overlapping with hydrogen, and D and F are going to correspond with chlorine overlapping with one of the methyl groups in the back. Okay. So, for example, if I rotated this 120 degrees to the right, chlorine would still be overlapped with a methyl. If I did it 120 degrees to the left, chlorine would be overlapped with the hydrogen, right? Okay, so we know that we're at some sort of staggered conformation in which chlorine is between being overlapped with hydrogen and being overlapped with the methyl, right? Because D corresponds to chlorine overlapped with the methyl, and B corresponds to chlorine being overlapped with the hydrogen. Okay, so we want to draw a staggered conformation. Just use the same setup with chlorine in the front, hydrogen down to the right, hydrogen down to the left. And then think about what rotations we could do that would put chlorine in between a methyl and a hydrogen, right? So if I rotated the back like that, right, 60 degrees each, rotated the back 60 degrees to the right, suddenly I would have a methyl here, and a hydrogen here, right? And this is basically the answer to the question, right? This is what you would need to draw to get the correct answer. And to prove it, we're saying when we know it's staggered, right, because it's one of the low energy ones, and we know if we move it to the left, chlorine overlaps with hydrogen, right? Chlorine would overlap with hydrogen if we moved it to the left. And we know if we move it to the right, chlorine would overlap with the methyl, right? There we are.